This is a pretty fitting place to me for me to be presenting a book about my experiences in the ocean, considering that some of my first memories of being in the sea were right down at Corona del Mar. Until recently, I had always thought that that calm, mellow, peaceful feeling of being in the water was all psychological. And up until a couple of years ago, when I started researching this book, I learned that it's actually physical. The ocean changes us in some pretty significant ways, and that's what this presentation is going to be all about. The second we put our faces into ocean water, something amazing happens. The heart rate lowers, breath rate lowers, brain waves soften, muscles relax, blood starts flowing more easily through the body's tissues, the metabolism slows. The deeper we dive, the more pronounced these transformations, these reflexes become. It becomes so extreme that at very deep depths, our bodies bear only a passing resemblance to our terrestrial forms. Now, scientists call this transformation the mammalian dive reflex, or more lyrically, the master switch of life. And they've been researching it for about 50 years. The term master switch of life describes not one, but many switches or reflexes that affect the brain, lungs, heart, among other organs that work in concert with triggers in the body to protect us from the immense pressures of a deep dive. These reflexes essentially turn us into deep sea diving animals. So ancient cultures knew all about the master switch, and they employed it for centuries and centuries to harvest sponges, pearls, and food hundreds of feet below the ocean's surface. Ancient sailors in the 17 and 1800s reported seeing pearl divers dive down about 150 feet and stay there for 15 minutes at a time.
Wow.
So everyone said, this is impossible. They came back with these reports. Everyone was like, you guys were drunk, you're exaggerating, you're just making this stuff up. Up until the 1950s, scientists said the deepest we could possibly dive and survive was 100 feet. Since then, competitive divers have gone down to 700 feet on a single breath of air, and the longest breath hold is 12 minutes and 30 seconds. So these guys have only been competing for about 15 years, and they've almost matched these fallacious reports of these 15-minute breath holds. So pretty interesting how quickly we're readapting ourselves. So how is this possible? How can our bodies survive in the stresses that are 30 times that of the surface? In water, the deeper we go, the more pressure increases and the more air contracts. Seawater is about 800 times denser than air, so this pressure increase happens very quickly. A dive down just 10 feet in water is equivalent to diving down 13,000 feet to sea level in air. So instead of like, when you're driving up to the mountains or in a plane and bags of chips expand, everything contracts, including human lungs. At around 33 feet, a depth of 33 feet, your lungs will shrink to half their size. At 66 feet, they'll shrink to a third of their natural size. At 99 feet, a quarter, and so on and so forth. You can imagine for someone like this, who's down at around 300 feet, this plays hell on his body. So how is he possibly able to survive in such pressures? That's what the master switch of life is all about. We all came from the ocean, and each of us literally has an ocean within us. Our human blood contains about a 98% similar chemical composition to seawater.
Wow.
The amniotic fluid in which a fetus develops is 99% similar to seawater. We grow fins first instead of hands, and are one misfiring gene away from growing fins instead of feet or hands. As we grow up and we're born, we are born to dive. The infant, when placed into water, can comfortably hold her breath for about 45 seconds, arguably longer than most of us here. She will begin breaststroking, open her eyes. This is without any training at all. We lose this skill when we're taught how to walk, but regaining it is pretty easy. Not super easy, but it's pretty easy. And I'll show you some people who have done a pretty good job of that. What I'm going to show you now is a video of a 300-foot free dive in a single breath of air by a French diver named Guillaume Neri. This video has been viewed about 20 million times on YouTube. I'm going to explain what is happening to Neri's body as he goes deeper and deeper and deeper, each of those master switches of life that are occurring within him. It's important to note that his body isn't really special. We all have these reflexes within us. We simply get in the water and they trigger automatically. And most of us here would be able to dive down to 75 feet, 100 feet, 200 feet. We just close our eyes and go. So right now, as Neri splashes into the water, the master switch starts kicking in. His heart rate will lower about 25%. Blood will start rushing into his core. His mind will enter a meditative state. Something else happens at around 35 feet, that's where he is now. This is really incredible, is his buoyancy will reverse. So you're gonna notice he's getting prepared to jump off this little cliff into this dark chasm below. He's not gonna kick his feet, he's not gonna move his hands, he merely needs to hop off it, and this sort of reverse of gravity, this reverse of buoyancy is gonna do the rest. And he will float effortlessly down until he reaches the seafloor. After 40 feet, everything turns around and it will keep falling until it can't fall anymore. He's getting ready, and there he goes. So, at around 150 feet, his lungs will shrink to the size of 2 grapefruits. His heart rate will lower even more. His body knows he's in the water and he will start reflexively conserving oxygen. Heart rates of free divers have been recorded as low as 14 beats per minute. Now that's about a quarter of someone in a coma. Some free divers have recorded heart rates as low as 7 beats per minute. Now, according to our understanding of our bodies, heart rates, our own physiology, that's impossible. Scientists say this cannot support consciousness, and yet deep in the ocean it does, and still no one knows exactly how. So he's approaching around 300 feet now. Blood is now engorging within his lungs to stop his lungs from collapsing under the pressure. His spleen will release about 15% new oxygenated blood. That spleen release usually only happens in times of shock and is met with a quicker heart rate, but the opposite happens here. His heart rate sinks even more. He gets this extra release of blood, which allows him to dive deeper for longer. He's about to touch down. He is cruising down, just effortlessly falling. And now comes the really hard part. He's got to make it back up 300 feet on that same lungful of air. His lungs are about the size of 2 fists. But you can see he's very experienced. He's doing a little showing off. He's doing a little air guitaring, some Superman poses. This guy has been freediving for about 20 years. He knows his body. He has saved 60% of his oxygen for the trip back. So as he goes back up, he is pushing against all that weight of the water. So he is just sort of climbing up there, and all those master switches are reversing. His heart rate starts increasing. Blood starts pushing back into his extremities, and his brain will wake up. He begins resembling his terrestrial form again. Free divers diving under their own power can't get the bends or decompression sickness. Our bodies naturally know how to purge all of that nitrogen buildup. Now he's been under about 4 minutes. I'm sure all of you are holding your breath along with him. He's gonna purge all of that nitrogen right here. He's gonna get to the surface, take a deep breath, and get prepared to go even deeper next time. So that is the master switch of life.
That's amazing.
So,
That's how I look at the blue hole
it is. So, we're not the only animals who have the master switch of life. Dolphins have it, whales have it, this guy has it. He's a Weddell seal. He can dive down to 2,500 feet and hold his breath for an hour at a time. The researchers who studied these animals found that they seem to gain oxygen the deeper they dove. Now, if you know anything about mammal physiology, that doesn't make any sense. They still don't understand how they do it, but this guy doesn't really care about our equations or what our scientists say. They've been diving down this deep for tens of thousands of years. They do it every day, and they always resurface in perfect health. So we're just beginning to understand the potential of animals in the ocean and our own potential in the ocean as well. So we also share a number of extra senses with oceanic animals. You could even call them sixth senses. To survive in a lightless, cold, and pressurized environment, sharks, dolphins, and whales have developed different senses to navigate, communicate, and see. We too share these extrasensory abilities. Like the master switch, they are remnants of our collective past in the sea. They're mostly latent and unused, but that doesn't mean they've gone away. We can re-trigger them when we really need to. The first of these is called magnetoreception. Now, just a warning, this is some very weird stuff, but I'll try to keep it pretty simple, straight and narrow. So we've been taught that we have 5 senses with which to perceive our environment: taste, touch, smell, sight, and hearing. The problem is, for an animal like the shark, how do they get from point A to point B and back again without seeing where they can go? Most of these sharks dive down, 1,000, 2,000 feet. There's no light down there. 12 hours out of the day, there's no light. But they're able to find their way throughout the ocean effortlessly. How do they do it? Many researchers believe that this has something to do with it. Don't try to draw this on a dinner napkin tonight like I did last night. It comes out looking very crude. So this is the Earth's magnetic field, and they believe that sharks are able to home in on the Earth's magnetic field and use it as a kind of natural GPS to find their position around the globe. Now, that should sound insane and far-fetched, but consider a number of other animals already use this. This is how butterflies get around. This is how birds get around. This is how turtles get around. It's probably how dogs get around, and they're able to travel thousands of miles across the country to find their owners. So it seems pretty reasonable that sharks would be able to use this as well. I'm going to show you something now. So in 2011, a group of researchers off the coast of South Africa tagged a great white shark called Nicole. Now this tag is what's going to let them know exactly where the shark was going, how deep, and for how long. 100 days later, the tag came off. They uploaded all the data, and what they found was totally amazing. Nicole swam from South Africa to the western coast of Australia, 7,000 miles in 100 days. That's pretty cool. But what was even cooler is she followed basically a straight line to get there. Now, there's no islands even out here, and they found that she was cruising at depths of like 2,000 feet. So how could she possibly get from South Africa to Western Australia? You say, well, it was random. She was just swimming around. Doesn't matter. Well, guess what? The next year, guess who they found at the same exact beach where they had first tagged her? They found Nicole at the same exact spot. So she was migrating to Australia and back. That's quite a commute, and she's probably been doing it every single year for as long as she's been alive. So how do they do it? These little dots on the shark's head are called the ampullae of Lorenzini, and they can pick up on the slightest electrical fields in the water. Great white sharks have extremely acute electroreceptive senses. They can sense as little as 125 millionths of a volt of electricity. That's not much. But these guys, the bonnethead sharks, can sense 1 billionth of a volt of electricity. And it's no coincidence that its head is shaped like a radar disc. That's a very efficient design when you're homing in on electrical fields. So just to give you a little perspective on how little 1 billionth of a volt of electricity is, imagine if I was holding a little camera battery, 1.5 volt camera battery, one of those teeny ones, and I ran 400 miles of wire to San Francisco. This shark could sense the electrical field at the end of that wire 400 miles away from a battery that big. So this sense is 5 million times more sensitive than any sense that humans have, and it's by far the most sensitive sense on the planet. So many researchers believe they're obviously homing in on the Earth's magnetic field, which is tens of thousands of times stronger than the fields they're already sensing from other animals. So sharks do it, bees do it, birds do it, we probably do it too. Ancient Polynesian sailors were able to sail incredible distances, hundreds, even thousands of miles from one island to another and back again. They could use the sun some of the time, they could use the stars some of the time, but oftentimes they weren't able to use either. Clouds would obscure the horizon, they'd be blown off course, and these guys were able to get to these islands back and forth consistently. How do they do it? These guys, the Gugu Yimithir, an Australian Aboriginal tribe, uses something called cardinal directions. They don't have words for right, left, forward, and back, but they do have words for north, south, east, and west. They want to make room for you on a couch. He wouldn't ask you to move to the right, he'd ask you to move west. They didn't bend backwards, they bent northwards or southwards. Now if you think about it, the only way they could communicate, they could use their language, was by knowing their exact position on the globe at all times. It's a very hard thing to do at night and an almost impossible thing to do in an enclosed space. But they did it all the time, and they weren't alone. Dozens of other cultures used cardinal directions, like these guys, the Echolocation of Mexico. Again, they didn't have words for right and left, but they do have words for north, south, east, and west. Some researchers from Holland heard about them and they thought they'd test these mystical abilities. So they grabbed one of these guys, they put him in a room, they blindfolded him, they spun him around about 24 times, they asked him to immediately point north, south, east, and west. Well, he did it without hesitating 20 times in a row. And then I think they just gave up and went home. So for many of us who can't find our way out of a parking lot, the idea that you're homing into some mystical Earth magnetic field seems pretty far-fetched and crazy. But consider we really don't need to use it too much nowadays, just like we don't need to free dive down to the ocean floor to gather food. But 400 years ago, we probably needed it. This is what New York was supposed to look like about 400 years ago. That's Manhattan. You need a pretty good sense of direction to make your way around there, especially through forested areas. This is what New York looks like now. You need zero sense of direction to make your way around. There are landmarks. Everything we build now, all of the settlements and cities are built around landmarks and street names, everything. And whenever we're in doubt, we can pull out our phones and know exactly where we are anywhere on the planet. So again, this is probably a latent sense. It's mostly unused, but when we really need it, turns out we can probably home into it. So the last thing I'm going to talk about is echolocation. I'm going to get a glass of water here. Now, this is not so much an extra sensory ability as it is a very acute sense of hearing. I'm going to show you a video here. So dolphins and whales use echolocation to see with sound better than we can see with our eyes. A dolphin can see an object as small as a rice grain from 300 feet away using echolocation. What they do is they send out a click and they wait to hear the echo of that click, and they use that data to form a picture of what's around them. It's basically a form of sonar. Whales, sperm whales, are the best echolocators on the planet. They can see a human from a mile away in the ocean, and they can see a foot-long squid from 1,000 feet away. This is just an example of how they echolocate, how they view the world. This goes on for a while. You kind of get the idea. That's the echo. It's going back into its head, processes the information, and you got it. So, pretty impressive. Humans can also echolocate. We're not quite as good as sperm whales, but we're pretty good. This guy is Brian Bushway. I met him a year ago. He's completely blind, not legally blind. He can't see anything. That thing on top of his head is a camera. So he has taught himself how to echolocate, just like whales, just like dolphins, to see everything around him. He rides his bike through busy city streets. He camps alone in the woods for weeks at a time. He lives a completely independent life. When I was with him, I sat across from him on a dining room table. He could tell the difference between a tennis ball and a Rubik's Cube by clicking and listening for that echo. So some researchers put Bushway and some other human echolocators into an fMRI, and they had him echolocate, and they looked at his brain, what his brain was doing. What happened is every time he echolocated, the visual cortex of his brain lit up. They said what he was essentially doing was seeing with sounds, the same way we see with sight. So instead of frequencies of light, which is how we view the world, he was seeing the world through frequencies of sound. He gave me a little lesson in echolocation. After about half an hour, I was able to find my way around a room. It turns on very quickly. So we're pretty good at echolocation, but again, we're nowhere near as good as the sperm whale. The clicks that we send out, they sound just like that, can be up to 80 decibels. The clicks that this animal, the sperm whale, sends out are at about 236 underwater decibels. Sperm whales are the loudest animals on the planet. They can hear each other from hundreds of miles away. Some researchers believe they can stay in contact with one another on the other side of the planet in something called the SOFAR channel. So these clicks are so powerful that they use them to stun squids, giant squids, which they eat. They could blow out human eardrums in a second, and they could vibrate our bodies to death with just the sheer sound of these clicks. So I'm going to show you what it's like to swim with a sperm whale clicking at you. This is of some researchers from about a year ago, and they were collecting audio data on sperm whales. And this is a very interesting thing that happens here with these whales, because they start clicking at you and then they get very curious because you don't look like anything else in the ocean. You don't look like a seal, you have hair, nothing in the ocean has hair. You have a large brain. Those clicks are so powerful they can penetrate through skin. So it gives a sperm whale a view of us from the inside and out. They essentially have X-ray vision, and you feel these clicks in the water. You feel them in your chest, and if you're around them for long enough, your body starts heating up. It's very weird. So this is what it's like when you've got some curious sperm whales who want to take a really good look at you from the inside out. He's getting a view here. You're going to see a sperm whale on the distance there. Really likes this cameraman. And I'll just kind of let you guys watch this. That's not coming from a boat, that clicking. That's coming from the sperm whale's head. So you're going to notice the whale flips on its back and it exposes its jaw. That's where they collect all those echoes. They aren't listening with their ears. See, he's getting a real good look at this guy. He's going to figure out if it's a squid, something he can eat. He's finally going to take a little deep dive and get a look at him from the other side. This researcher who is filming this right now had a calf come up to him and try to bump into his camera. So he decided to put his hand out to stop the calf from bumping into him. Its head was vibrating so violently with these clicks that his hand was paralyzed for about 4 hours. And then he came back to normal. So I know what you're all thinking. You're like, why the hell would anyone want to dive with sperm whales? These animals have 8-inch long teeth. They are the world's largest predators. Well, it turns out the only way to really study them is to free dive with them. Scuba freaks them out. Their hearing is very sensitive, and they don't like to be around scuba. They don't like submarines. They don't like robots. If you're going to get this close to a sperm whale, you have to free dive with them in your natural state. So this is a different type of free diving for research, for a greater good. Something also amazing happens when you free dive with them. Instead of swimming away from you, they're surprisingly very shy animals. But when you free dive with them, they don't only not swim away from you, they sometimes turn around just like this and they welcome you into their pods and they begin peppering you with this echolocation. And they also start sending out coda clicks, which are used specifically for communication. We know that sperm whales are communicating with coda clicks. These are two very different things. They start sending these to freedivers. So what many of these freediving researchers are doing, these are the guys I wrote about in the book, is collecting this data because they believe inside of these little coda clicks is a very sophisticated form of human communication that they hope to crack one day. Now, I know that sounds pretty crazy, it should, but just consider a few things. The top of that head, that's two sperm whales looking straight at you. That's what they look like. Is a brain 5 times the size of yours. Sperm whales have a neocortex, which neurologists have long associated with conscious thought, future planning, and language. And that neocortex is 5 times larger than ours. Sperm whales also have something called spindle cells. These are highly developed brain structures that have been associated with compassion, love, suffering, and speech. Basically, all those things that make humans human and separate us from great apes. Sperm whales have them in a far larger quantity than we do. And they've had them for 15 million years longer than we have. The current size human brain is about 200,000 years old. That's how old it is. The sperm whales have had their current size brain for 50 million years. They don't need to have such a huge brain to control their body. A whale shark, which I'm sure some of you know, maybe some of you have been lucky enough to swim with or dive with, their brains are about that big. And whale sharks are 40 feet long, they're enormous, and they can control their bodies just fine. Brains take up a lot of real estate, a lot of energy. There's a reason why an animal has a big brain. What are they using it for? What are they doing when they float around like this and send these coda communication clicks back to one another for hours and hours and hours? They surround freedivers like this too, and they start sending these clicks out. What are they talking about? We know they're communicating, we just don't know exactly what they're saying. Hopefully that's going to be changing pretty soon as these researchers do more and more freediving research. So these are just some of the questions that this band of DIY freediving researchers are now trying to answer. I was lucky enough to spend about 2 years with them researching these animals, freediving with these animals, implying the many mysteries still untapped beneath the surface. In a nutshell, that's what the book is about. Thank you very much for sticking around. We'll do some questions now, if anyone has any questions. Yes, sir.
That last photograph, did that whale have something in its mouth, or is that?
That is the sperm whale eye,
Right.
and that is a remora. They don't have hands, so they can't get rid of them. But I mean, you just kind of look in that eye, and this isn't a scientific observation, but you just kind of figure something is going on in there, and that's what they're trying to figure out.
What direction are we looking at? Where's the front end and the back
The front would be to the left of the screen, and its mouth is below that. They only have teeth on the bottom row of their mouths that they open up, and its tail would be over where I am.
Such a gigantic animal, and yet it has such a small mouth.
Its mouths are pretty big if you're diving with them. Those teeth are pretty big too. So it doesn't need that big. I mean, they're highly evolved. They have a very efficient design. What they found is, their favorite food is giant squid. They can dive down to about 10,000 feet, and they shoot out these sonar blasts, stun the squid, and eat them. That's the only way they can catch up to these squid. Squid can cruise at around 35 miles per hour. Fastest they can go is about 25 miles per hour. That's the only way they can hunt them. And it's very surreal being in the water and hearing these echolocation